Okay, hello today. Thank you for participating in today's session in our video series about securing cyberspace. Today we have a special guest. Very pleased to have you here, Professor Yehuda Lindell. Welcome, Shalom. Today we are going to talk about, we are following the series on key management solutions, and we are going to have a discussion with Professor Yehuda Lindell about his being an expert in the field. So we'll have three parts. First, introducing Professor Yehuda Lindell, talking about the company he is working in, then introducing the key management solution from their perspective, from the perspective of the vendor, from the perspective of the ones making sure that those solutions do what they need to do, and also closing and wrapping up the session about what makes the solution special, how it distinguishes itself, and what is actually also on the roadmap to address specific challenges that are still to come. So welcome again, Professor Yehuda Lindell. It's a pleasure to have you here. He is the CEO and co-founder of Unbound Security, and maybe you can say some words about yourself.
Yeah, thank you very much for having me. I'm very happy to be here. So myself, I guess what I would say is, even though I'm CEO of Unbound Security, I'm really a cryptographer by trade and just playing CEO on the side. That's who I am. I've been doing cryptography for 23 years now. So yeah, I started my PhD in 1998, very much focused on secure multi-party computation. It started as pure theory, and I did a lot of research around feasibility and what's possible, what's not possible, in what way, and then was really a part of the research effort to make it more and more efficient enough to be used in practice. And then I took the one additional step beyond that, which is of commercialization. In academia, we can sit back and say, we have this great technology, come and take it, but no one's going to come and take technology in its early stages. We really need the inventors and the scientists to go out and help that process. And that was really a part of starting Unbound, and that's where we are now. I'm a cryptographer, but running a company.
Very cool. So you're saying 23 years working as a cryptographer. So it's very cool to have you here. So a question: did you choose cryptography, or did cryptography choose you? So how did this?
Yeah, so it was a bit of a mix. I did my master's thesis in data mining. At the time, it was the very early days of data mining, and it was too empirical, and I felt I wanted something more mathematically rigorous and more theoretical. And so I went to the Weizmann Institute, and I was looking at all different areas of theory. And what really attracted me to cryptography is that, on the one hand, it has beautiful mathematics behind it, a very strong and powerful theory, but it's also very close to practice. And that's very, very unusual in research areas. Typically, the gap between what you're doing in research, especially theory, and what's actually being used is huge. But in cryptography, it wasn't that. In fact, I started consulting in my second year of my PhD. And I found that what I really need the most is the cryptographic mind of adversarial thinking. So whatever you look at, what you think about is, how do you break it? Or how can this be bypassed? And then how can you build something that would prevent somebody else from bypassing it? And that combination of beautiful theory and close to practice very, very much attracted me.
So what was the idea then behind Unbound? So this question is kind of self-answered, right?
Well, Unbound was certainly about taking the next step and going to commercialization. But that's not an aim within itself. And in fact, for years, people said to me, with what you research, don't you have a startup you want to do? And I would always say, I'm a happy academic, leave me alone. I don't have any, I'm not thinking about that. But then one day I got an idea that I felt it would be criminal to ignore. And the idea was really around this problem of key protection, that until now, you either needed dedicated hardware or you would just put a key somewhere and not protect it on a machine. And I realized that with the technology and the science that I had been researching called multiparty computation, that we'll talk about later, you're able to split keys and never have them in any single place at any time. And now solve this very difficult problem of key protection with a completely new paradigm. Instead of saying, I'm going to build a fortress around this key so no one can get to it, I'm going to say, I'm going to split it into multiple places and with strong separation, make it very, very hard to steal. That was the initial idea behind Unbound. It was sort of like a eureka moment that, once again, this problem that I've been researching, that typically in academia, people are applying it in different areas, can actually be used to solve this really critical problem now. And when I had that idea, then I felt that I couldn't ignore it because it just felt right. And was also then did indeed fulfill that what I said beforehand in that series that was rather natural of going from practical research to being part of commercialization.
So, and for what stands Unbound for? So, in addition to commercializing the cryptographic primitives, let's say, and the cryptographic technology for the market or for people out there.
Yes, I think Unbound as a company stands for something very simple. It's to make deploying and using cryptography easier by virtualizing it. Everything in modern systems is virtualized. We don't have physical anchors typically anymore. Even virtual machines now are considered heavy with, in the world of containers. So we need to make our cryptographic infrastructure modern like everything else. So I think the simplest way to describe Unbound is we virtualize cryptography.
You virtually, very cool. So talking about this, and this is where myself came into contact with Unbound about the key management solution that you are providing. But before we go into the details of that key management solution, I would like to understand a little bit more in a general term. So what is your understanding about modern IT and what is the impact of an enterprise cryptographic infrastructure? So what is cryptography? What impact has cryptography on it?
So when I think of modern IT, I think of two main elements. One is, as I mentioned earlier, that everything is virtualized. So we no longer, we have very few machines that we're going physically to access and to install. We're setting up virtual networks and virtual machines everywhere, and that's the way we're working. And the second element is that we're no longer running and controlling our own data center, and that's where everything resides. Rather, we have multiple data centers. And we also have multiple clouds. So we have a hybrid and multi-cloud scenario. And enterprises aren't going to one cloud. And the reason is that different clouds provide different benefits. And it's the business unit who wants a business solution and business benefit who's saying, I want to go to GCP for this. I want to go to AWS for something else. And a different business unit wants to go to Azure because each one is giving them something different. And also multiple other smaller clouds out there, actually. So we now have the situation where I have multiple physical data centers that I'm running. I have multiple clouds, and within those multiple clouds, I have multiple regions. And that makes my infrastructure very, very complex and fragmented. So now I need to manage keys when I look at the cryptographic side in all of these different places, but they work in different ways. They provide different interfaces. They have different management and consoles. They provide you different features. That becomes incredibly complex. How do I, for example, one very simple thing, how do I enforce company-wide policies on cryptographic keys? It's very difficult in such a fragmented landscape. And there are many other problems as well.
So you just said that now companies are paving the way to the cloud, and they don't go only to one cloud. And I really like understanding this business perspective, that's saying the business is driving this multi-cloud environments, because this is what what you need, and this is why this is happening. Many questions that I usually have, and especially from a security perspective with clients going to the cloud, one of the doubts they have is whether they are future ready for the cloud and they can still leverage, let's say, existing investments that they have. And also you mentioned about, well, now that I had something centralized in my small data center where I knew only person Y and X would have at least physical access. Now my data or my processes I spread all over different data centers and even different providers. And you just mentioned that, well, you need kind of also centralize all of this, and especially when it comes to sensitive pieces of information, as for example, cryptographic keys.
Yeah, so I think that when we think about being future ready and leveraging existing investments, so there are two elements. One is when you're choosing a new solution now, you need to think about, is that solution one that will help me go to the cloud and will help me be cloud agnostic? In other words, I can move to different clouds. I'm not locking myself into one specific cloud. Or is it something that's very, very specific to what I'm thinking about doing right now, and later on is going to inflict a lot of pain? There are some companies that say, okay, yes, now I'm going to AWS and that's where I'm going. And I'm not worried about, I don't want to think now about what's going to happen later on. And they typically very quickly find out that actually things are much more complex, and even just being in AWS is difficult. And that really doesn't answer all of their needs, and they'll need to go elsewhere as well. So think about, is a solution one that locks you in somewhere or not? That's a very important element. And the second thing is, it is possible to indeed leverage existing and on-premise investments by virtualizing them. And one, it's important for me to stress, when I say we should be cloud agnostic, it doesn't mean that you shouldn't use AWS's cloud HSM offering or their KMS, but rather you should use it as much as possible via something that will enable you to also move elsewhere. So it won't lock you specifically into that. So your code, if your code is accessing directly a cryptographic operation, then do it via something that is more general, and as I said beforehand, I'll say it again and again, that virtualizes those different pieces of infrastructure, whether it be a cloud HSM or a physical HSM that you hold, or a cloud KMS, you would like to access and manage all of those in the same way. And that's very much about what Unbound is doing.
Okay, so we know that virtualization in many manners, it makes things easier for companies, or even for deploying infrastructures and being portable from one environment to the other. But are there any specific challenges for the clients aiming to adapt your solutions, especially when we're talking about the key management solution that is virtualized with respect to organizational or procedural or technical and compliance perspective that you have come across through your experience so far?
So I'd like to say no challenges, everything is easy, but it's infrastructure. As soon as you're touching infrastructure, of course, there are some challenges. And I think the main challenge that organizations have is that they have legacy solutions that actually very often are very unhappy with, but they're just not excited about touching their infrastructure. So often what we're seeing is that they will move to a more modern solution when they're forced to, either it's a completely new initiative, and then they don't need to use a legacy solution for that. And unfortunately, there are a lot of new cryptographic initiatives today because cryptography is becoming much more central to what organizations are doing. And the second is when they have to, because, for example, they do want to move to the cloud, and then they need to adopt something else, and they don't want to make the same mistakes beforehand. So the main challenge is just, the classic computer science, software engineering mantra of if it works, don't touch it. So at infrastructure, that's really the main challenge that organizations have. The second relating to compliance is that FIPS 140-2 is a classic standard that everybody would like to uphold, or at least want to know that the solutions fit that. And some organizations have self-inflicted compliance about the level. There are different levels of FIPS. There's 1, 2, 3, and 4, and 3 and 4 are only related to hardware. Now, when you move away from a hardware solution, then you can't support levels 3 and 4 anymore. And then there are questions about, well, can I just say I don't really need them because the attack vector is not a physical attack vector when I'm looking at modern data centers? Or do I still want to support the higher level, and then a pure software solution is not relevant? And in order to help organizations with that, Unbound doesn't come along and say you should use our software-based MPC Vault only, but rather we enable you to use all keys in all stores in a unified manner. So if you have a business problem that requires requires that you want to use level 3 or 4, you want to use a physical HSM, that's fine. You can actually use it exactly the same way that you use any other key store via Unbound. So we help organizations become more flexible and agnostic, even while maintaining legacy compliance requirements.
Okay, so with Unbound, even though it's a virtualized solution, you are not only open towards the different KMS that are out there on the cloud providers, which you can centralize them and have a single pane of glass through them, but Unbound key management solution also open towards hardware security modules that would allow you to have a higher FIPS level if that is what it is needed from the requirements. Okay.
Absolutely. The way I think the best way to describe it is, what's a virtual machine? It's software that provides you the same functionality irrespective of what hardware it's running on. And that's the same thing. Unbound's virtual HSM and virtual key manager will manage and enable you to consume cryptography, whether it's in a KMS, a cloud HSM, physical HSM, smart card, virtual smart card, all of those, in any of those environments in the same way, and then overcome the problems that we have with the fragmented landscape. So, having a single audit for all different environments, a single place to set policy for cryptographic algorithm, key sizes, and usage, solving the problem of this error-prone practice of manually repeating the same process in different key managers, a unified backup of all keys, automatically synchronizing keys across different key stores. All of that is solved by using our orchestration platform.
So all of these are advantages when we have a centralized single pane of glass through all this sensitive, especially this particular sensitive data that hold other data confidential and also integer. One question that of course arises people out there listening to it is, but didn't we say that we're centralizing everything? We have a single, let's say, point of failure. So how to deal with this? So is this really a single point of failure? And maybe we can go to the idea. So what makes the solution special in order to address such a challenge?
Yeah. So I guess it's, in some sense, it's decentralized centralization. It's conceptually centralized, but it's not actually physically centralized. And I think that's what's really important, or centralization with diversity. So yes, you'll have centralization in the sense of a single way of working. You will access and manage and consume cryptography in the same way wherever it is, but the keys are not sitting in one place. And in fact, when you use our MPC solution, which we'll discuss next, their keys are by definition split, so there's no single point of failure. When you're using other key stores, it depends, of course, on the security of that key store, but the Unbound Key Manager naturally enables you to be across different environments, different clouds, different regions. Because it's software, so it comes with high availability, it comes with disaster recovery, all built in, synchronization of keys across different places. So to prevent key theft, it's the splitting of keys or utilizing other solutions if you wish. And for high availability, it's software, so it actually provides you all of those advantages of being able to get just built-in high availability, disaster recovery, and so on and so forth.
Mm-hmm. So that make us go naturally to the question of, well, maybe you could explain a little bit of what actually you have been researching all of these years, or especially what it caught your attention and you will become an expert in the area about multi-party computation, which seems to be actually the holy grail behind of this decentralized, centralized concept of having one single pane of glass for working, managing, auditing, and getting the compliance, while you still have some decentralized concept within it.
Okay, yeah, so we have mentioned MPC multiple times, but haven't actually said what it is. So, yeah. So what is MPC? It's this beautiful and surprising notion that you can compute on data without actually bringing it together. And the way it was originally thought about wasn't in the context of key management. So I'll start with that. Think about a group of cryptographers sitting at dinner, and they want the cryptographer with the highest salary to pay for dinner, but they don't want to tell each other how much they earn. So can you actually do that? Is it possible to work out who has the highest salary without revealing to anybody at all? We're cryptographers, we don't trust anybody. There's no third party will say, yeah, we'll trust that that person. Will just whisper in the waiter's ear. No, we don't want to tell anybody. And in fact, it's possible to do any such computation. So you can think about amazing things like two people comparing their DNA to see if they're relatives or something of that sort without actually revealing their DNA to each other because it's private information. Or a bank and a credit card company doing analysis on their customer data to improve their fraud prevention, but without revealing that customer data to each other because, of course, they cannot. It's private information. And can compute statistics. We'd like to compute statistics on like a census, but without actually me having to give my raw salary data, personal family data, and so on and so forth. But I keep my own data, and at the end, the census organization will only get the final result. All of this is actually possible with multi-party computation. And with this, using these same ideas, we can also use that to protect keys, because instead of taking a cryptographic key and putting it on one machine, and if we were talking about this before we knew about MPC, was of course I have to hold the key in order to compute on it, because to encrypt or decrypt or sign or any of those operations, verify that a password is correct, verify a biometric image, I need to actually compute on it. I need to look at it and make comparisons and make computations. No, with MPC, you don't. What I can do is I can take a key and randomly split it into two or more pieces so that each piece means nothing. Like if the key was the number 135, then I can make one piece be 32 and the other be 103. And then I can change that in an hour to be one piece being 75 and the other piece being 60. And each time I can make this change so that the two numbers add up to the key, but in a different way. And if I only get to one of those machines, I see a number 35 or 65 or 84. It means tells me nothing whatsoever about the key. It's only if I get to both pieces at the same time. Why at the same time? Because I'm continually changing the sharing. Externally, it's the same key all the time because we need that to support our business solutions. But the actual key is the sharing changes. And the beauty of MPC is that I can generate this key in this split format. I can carry out the computations, whether it be signing or decrypting or encrypting or password verification, whatever it is, without ever bringing it together. So there's never any single place that an attacker can come and steal that key. And what that means is that now by having strong separation between those two or more machines, and we have customers, for example, who are putting them in different clouds, one in Azure and one in AWS, or one in AWS and one in their own data center, or they're both in their data centers but with different administrators, or even different operating systems. So as much as you can separate between them, you now make it very, very hard for an attacker to get to both pieces.
So the multi-party computation, it's something what I have encountered during my computer science studies, and there were a couple of concepts with which myself was also puzzled. So the first time I was myself in touch with the technology, I remember that was this two multi-party computation. It was a let's say a lab software called Fairplay, with which I tended to do a seminar work at the university. But at that time, that was this two-party. So now we are able to do multi-party computation. And as far as I remember, there was the technology behind this were called Gauss-Gerbaud circuits. Is this something what Unbound is this kind of the technology that lies behind of Unbounds?
So Unbound has developed protocols that are the best possible for each different cryptographic function. So for symmetric functions like AES encryption and decryption, indeed, we actually do use garbled circuits, or a variant of, obviously very different to what you played around with Fairplay about 15 years ago, probably,
exactly.
maybe a little bit less. But it's, yes, that technology is useful for symmetric, but for RSA, for elliptic curve operations, and for others, we have different dedicated protocols that are much, much more efficient.
And about what also I remember talking about, because you're saying like we are sharing the key, so we kind of have this idea of keeping the key secret to the different parties. So each of the parties know only one share. And I remember that was puzzling me was the idea of secret sharing from Adi Shamir, which is only a 2-page paper, and it makes use of the Lagrange polynomial. So that was also one of the things that kind of make me enthusiastic also myself about cryptography. So are you using something similar for doing the shares between the parties?
So we use that in some cases. So the basic product today for basic key management, our MPC Vault, it's a sharing between just two. And then we don't need to use the Shamir sharing, but rather just simple XOR sharing or additive sharing, depending on the type of key. For cases where you do want to have what we call quorums to approve, for example, signing or something like that, then yes, we certainly rely on Shamir secret sharing. But for most of the basic cryptographic operations, it's currently 2 of 2, and you just repeat multiple pairs. There are actually many operational advantages to the simplicity that you get there. But our solution, the technological core supports both, and what we productize really is about what our customers need. For the classic cryptographic operations, we found that 2 of 2 is what makes most sense. And in some areas, for example, with digital signatures, there's more interested in larger quorums, and we have some solutions with that as well.
So you before just described that this the idea, it was not let's say the idea of having this multi-party computation, or the concept behind it, it's not about the keys, but you derived, let's say, problems that mathematicians or cryptographers do come up with, and try to find solutions, as you described before. And also you mentioned also other use cases which are really relevant for our everyday life, and maybe also in the future when we talk about for example, finding cures for a specific disease, and making sure that those are still confidential to the persons, and they keep their privacy. So is this unique to Unbound, or are there also different solutions out there in the market?
So Unbound was one of the first, but there are certainly other organizations that are doing MPC, but primarily in different areas. So there are, in the cryptocurrency key protection area, there are a number of companies. Unbound also, we provide key management and protection for all types of keys that an enterprise would need, and financial enterprises are looking for cryptocurrency, so we also deal with that. But we're the only one that really covers the full suite of cryptographic needs. There are a couple of other companies that are also looking at solving privacy problems, machine learning, while keeping the data private, or collaboration between different organizations. Over the last 2 or 3 years, there are more and more startups doing it, and there are other large organizations that are also looking to use MPC. Google uses it for working out the financial benefit of certain ads being shown when they need to compare between actual purchases to ads being shown. So it's becoming more and more accepted and used in industry after there was exposure from what academia has been doing over these last few decades. But Unbound is probably one of the more mature of those companies out there.
Your roots, because you were mentioning financial sector, so your roots up until now or up until last year were most notably within the financial sector. So I maybe would like to understand a little bit better why is
so most of our customers are large financials, banks, and so forth, and also large technology companies. And the reason is that they have a combination of a history of cryptographic expertise, and more importantly, they really care about security. And although that may sound funny, but until a few years ago, most organizations didn't care really about security. They cared about compliance maybe, and they needed a checklist and to say, yes, we're doing our best. Yes, we crypto the AES tick, and this sort of approach where we do what we have to because we don't have a choice, but security is just a pain that we'd like to minimize as much as possible. That wasn't the case. Financials and banks have really cared about security for a much longer time, and also large technology companies. We're seeing that the world is changing, and organizations now realize that more and more organizations and sectors realize that security is actually critical to their business.
So, and maybe this is also one of the cases which is becoming true, as far as I know, Unbound Core was recently selected by a major law firm, by an international major law firm. So what commonalities are you seeing between, let's say, the financial and the legal sector?
So I think the legal is a great example of probably 20 years ago having very little familiarity with cryptography. But it's certainly an area that has come to the realization that cybersecurity is a massive threat to their business. If their confidential customer data is stolen, that's almost the end of them, right? They're going to go out of business. If I can know what my legal adversary is researching in preparation for a trial, then I can use that strongly against them and have an unfair advantage. So the legal sector is realizing very, very quickly that they need to care about security much, much more. And that is why I believe that change is happening. And indeed, it's an area of great interest for us as well.
So what takes Unbound from simple key management to, let's say, enterprise cryptographic orchestration in that sense? So we just heard a lot about what makes Unbound key management solution very special, also in comparison to other solutions out there. But what makes it going from the simple key management to an enterprise ready solution?
So I think two main elements. The first is this the breadth of our solution, the fact that we virtualize all key stores of all types in all environments. We're not, many organizations, our competitors will manage their own keys. the keys that are in their key stores. But as cryptographers, we said that we want to help enterprises deploy and use cryptography well. We don't care where the key resides. So they don't have to use our MPC vault. They can use a cloud KMS or an HSM, depending on what their threat model is. I can have my recommendations, but they need to be comfortable with the decisions they're making. What I want to do is support them in whatever their choices are. So being able to support all different key stores in all different environments, being able to provide an interface for all of the standard libraries, PKSS11, OpenSSL, CNG, Microsoft CNG, KMIP, Java Crypto, a modern RESTful API, all of those are supported by Unbound, meaning that we can support all of the applications out there and all of the cryptographic needs that organizations have. The second element beyond the breadth is that we also go a step beyond protecting a key from being stolen or preventing a key from being stolen, but we also prevent a key from being misused. And this is something which is important to understand. There are some cases where one malicious signature is enough to cause huge damage. And an Unbound system is the first to introduce a key misuse protection layer, something like a cryptography firewall, you could call it, that not only ensures that a key is not stolen, but also that this request is actually legitimate and is allowed to, we're allowed to process it and actually carry out that cryptographic operation, and it's not fraudulent.
Okay, so this sounds fantastic. So what other security, let's say, or puzzle pieces does Unbound address and offer in their portfolio? In addition, let's say you just mentioned, maybe you want to elaborate a little bit more on that, and or mention others that makes Unbound especially out there.
So I think that we can think of Unbound at three layers. There is a bottom layer where there are all the key stores, and there's also Unbound's MPC vault. The layer on top of that has the virtual HSM and the virtual key management component, so that you can manage keys in any of those key stores or consume cryptography in any of those key stores via the virtual HSM, and irrespective of where the actual key is, we'll take care of all of that mapping for you. But then you want to solve in the end a business problem. You have private data you want to encrypt, or a database you need to encrypt, or something needs to be signed, or a machine identity or human identity. You need to solve a business problem. And Unbound has an entire layer on top that helps you to do that. So we have a very, very rich code signing solution, which is extremely important today in the era of supply chain attacks and more. PII tokenization comes built in with our solution. App-level cryptography, so encryption and signing of all types via any application that needs to consume cryptography. We integrate into the to encrypt infrastructure like storage or virtual machines, databases, secrets vaults. You can use Unbound to protect identity via PKI, or with virtual enclaves on endpoints like desktops or mobiles. And we also provide a solution for protecting keys for cryptocurrency and blockchain key management. So really, that upper layer says, we're not just going to manage your keys and enable you a very basic API. We're also going to go and help you with the next step, which is to solve your actual business problems, which is really what it's all about.
Yeah, that sounds more than fantastic, I would say. I had just said before, it sounds fantastic, but it sounds more than fantastic. It's a lot of challenges that can be addressed on one place, and makes this as easy as possible towards the users and the one that are having those challenges. Nevertheless, one last question that maybe I would like to have your opinion as a cryptographer. So a lot of time, or in the recent, let's say in the last 10 years, we're hearing a lot about quantum cryptography or quantum computers. And in the 10 days ago, more or less, the NSA put it out there like a frequently asked question about these challenges that people are maybe concerned. So how does Unbound address these challenges when let's assume we have quantum computers out there how does this relate, or how Unbound thinks to address that when this area is practice and not theory anymore?
So let me start with saying if rather than when. I think that's an important thing to understand. As cryptographers, we always want to be ready. So we need to have solutions in place so that if something happens, even if it's a low probability event, we need to be ready, because if we are unable to secure the internet and our digital infrastructure, modern society will almost collapse, or I don't know if it'll collapse, but it will be complete chaos. So we can't afford to have that happen, and therefore we need to be ready. And therefore there's this entire area of post-quantum cryptography, which is cryptographic solutions that remain secure even if there are quantum computers. And there's a lot of research being done on that, and it's now under standardization in NIST. But it's important to understand that we don't need to panic. There are companies who are selling quantum cryptography and post-quantum, and they're telling you need to have this now. No, you don't need to make any changes right now, because there are still a lot of major challenges. And this is also what the NSA said, but this is what most cryptographers are saying, is that be aware that this can happen, but it's not happening very, very soon. In fact, it may not even happen at all, because there are very major physical challenges in building large-scale quantum machines. Having said that, what can I do today? What should I do today? And that's to be crypto agile. Being crypto agile means that whatever solutions you deploy have the property that it's not difficult to switch out an algorithm for another algorithm. Now, you should be doing this anyway with cryptography, because sometimes schemes get broken or key sizes need to be changed. And when you're not crypto agile, it can take you a very long time. And we've seen this in the past as well, and it's very unfortunate. So today, if you're crypto agile, that's really what you need to do, so that if in 10 or 20 years a quantum computer is built, then you'll be ready and you'll be able to change over to a post-quantum secure algorithm, and you won't have any threat from that large-scale quantum machine. Of course, very small quantum computers do exist, but there's a big difference between that and a large-scale one. Another thing I want to add is this notion of quantum cryptography itself, or quantum key distribution, that a lot of companies, or some companies, are pushing very hard. The consensus amongst most cryptographers, but also GCHQ in England and the NSA and more, is that this is just not a solution that makes sense. It's solving the wrong problem. It isn't needed by organizations. Maybe you can think of some very, very rare cases where it would make sense. In general, it does not. And it has a lot of security problems within itself. So I would stay away from the noise and the hype. In general, let's wait for NIST to standardize what they want to standardize. If you come and say, but I have this data, it has to be secure for 30 years, let's have a discussion about the best way that you can do that. And there are good ways of doing that today, but there's no need to panic and no need to run after making major changes today.
Thank you. I think that was very, very good to know, and very, let's say, gives you a different perspective and aspect on that, and not panicking, as you just said. So thank you for being here and for making our, as a special guest, also our series special this time. Thank you, Professor Yehuda Lindell. It was a pleasure to have you here. Toda rabba for your time, being part of this series, and hope to see you maybe in another session and learning a little bit more about cryptography in general.
Thank you very much. I was happy to be here.
Bye-bye.